We're going to go ahead and start a new module, which is module 8, and we're going to go right to 8.1, which is the multiplication property of exponents. We're going to learn one term in this particular section, so we're going to learn what a monomial is. And a monomial is just a number, a variable, or a product of a number and one or more variables. So some examples: this is a monomial. This is a monomial for x, 4 times x. This is 1, 2, 3 times x times y. So notice it says product, which means multiplication. 2/3 times x and negative 5 times x. So all these are examples of monomials. And this is going to be important for sections that we deal with a little bit later on. So first thing I also want to go through is kind of a little bit of a review. So again, this is just reviewing. If you recall, 2 to the 0 or anything to the 0 power is always equal to 1. So if we have x to the 0 power, that is 1. If we have 1 million to the 0 power, that is also equal to 1. Okay, 2 to the 1 is equal to itself. So 2 to the 1 is just equal to 2. 2 squared is equal to 2 times 2, which is equal to 4. 2 to the third is 2 times 2 times 2, which is 8. And 16 is 2 to the fourth. 32 is 2 to the fifth. And just some of the numbers that we're dealing with. Remember, these are all multiplication of the same base. So what's important about these numbers here is this is what is known as my base, and this is what is known as my power. So we're going to be dealing with that as we go through these problems as well. So we want to figure out what is 2/3 times 2 squared. So we're multiplying those two together. We can do this the long way. We can say 2 to the third, if you remember, is 2 times 2 times 2, and then times 2 squared is 2 times 2. So notice that we have 2 times 2 times 2 times 2 times 2, which is 2 to the 5th power. We've already calculated that number, which is this one right here. And we know 2 to the 5th power is equal to 32. Okay, but notice in this case, there's a special property here. So notice if I have the same bases, so notice I have 2 for the base of both of those. It doesn't matter what the powers are, but if I am multiplying two numbers with the same base and whatever power it is, but the same base is critical, we have to have the same base here. Then all I have to do is add up the powers. So notice that we have 3 plus 2, which is equal to 5. That gives me 2 to the 5th, which is then 32. Because remember, 2 to the 5th is not 2 times 5. It's 2 times 2 times 2 times 2 times 2. Okay. Here's a special property, which is a negative. So here's one of the rules that you have to memorize, or at least have written down so that you can reference it when you're taking a test. But we have negative 2 to the 3rd power. And negative 2 to the 3rd power is really just negative 2 times negative 2 times negative 2. And when I multiply those together, these two multiply to positive 4. And then 4 times negative 2 is equal to negative 8. Now notice that it is negative. Okay, now how do I know that's negative, and what is the shortcut that I was talking about with the rule? If this power is an odd number, so it could be 3, 5, 7, 9, 11, 1,001, 1,025. So as long as it's an odd power, it's always going to be negative. If it's an even power, then it's going to turn out to be positive. So with an odd power, and of course what's important is that it has to be inside of parentheses. So this inside of parentheses is also another really crucial part. You also need to understand that there is a difference between negative 2 to the 3rd and negative 2 to the 3rd. Notice in this case, the negative is to the 3rd power, and in this case, this is 2 to the 3rd times negative 1. Okay, and there are very different problems, even though in this particular case they would give you the same answer. But if that was an even power, they would not give you the same answer. So we're going to go through a problem kind of like that. So notice that it's negative 2 to the fourth. This is an even power. Notice we have parentheses around that, so that means that the negative is also to that power. So this would be a positive 16, or just 16, which is really 2 times 2 times 2 times 2. Okay, so it would be positive 16. Now, of course, if I had negative 2 to the fourth, that would equal negative 16. Now, why is it negative 16? Because we take care of the exponent first, and then we multiply it by negative 1. Okay, in this case, we don't do that because we have the whole thing is to the fourth power. So this is, again, really just negative 2 times negative 2 times negative 2 times negative 2. And, of course, this becomes positive, this becomes negative, and this becomes positive when we do the multiplication through the numbers. Okay, so now, how do we find 2 times 2 to the fourth? Well, we can use the property that we have above. Notice that we have a pretend 1 there, so we can see that a 1 actually exists there. So this would be 2 to the 1 plus 4, which is 2 to the fifth power. That's one way to do it. We can also see, of course, that that is 2 times 2 times 2 times 2 times 2. Now, why do I know that? Here's the first 2. And then here are the other 4 2's. And how many 2's total are there? 5. So it's 2 to the fifth. And of course, we know 2 to the fifth is 32. Okay, so we're going to get into some homework problems in the next videos.